We said before that antibiotics are beta-lactam and non-beta-lactam. Beta-lactam concerning the penicillin and cephalosporin. We finished here the penicillin and we will start the cephalosporin. Cephalosporin, as we see the structure, is somewhat different from penicillin. Here the red arrow shows a 6-membered ring and not 5-membered ring as penicillin. In addition, this ring having a double bond. Penicillin, we don't have a double bond. In addition to the position number 3, we have no a carboxylic moiety, but we have an acetyl oxymethyl group. So this ring is an acetyl oxymethyl group. The nomenclature of cephalosporin. The left one is known as C-fam. C-fam. And as we see here, like penicillin, the sulfur taking number 1, and we finish this ring first, then we go to the beta-lactam ring. In the right side, this is C-fem. Why we change from A to E? Because we have a double bond. The other structure is known as 7-amino cephalosporanic acid, or the abbreviation is 7-ACA, amino cephalosporanic acid. What is the difference between the cephalosporin or PNAM and the CFEM? As we see here, that the beta-lactam in CFEM is less strained than in PNAM. Why? Because it is fused with 6-membered ring and not 5-membered ring. In addition, there is an olefinic linkage at C2 to C3, so it is less reactive. The beta-lactam here is attached to a 6-membered ring, and we have a double bond, so this make it less strained than in PNAM. As we see here, the cephalosporin C cannot be taken orally. Why? Because the side chain acetyloxymethyl by esterase enzyme, if you take it orally, it will be break here by esterase enzyme, then undergo reaction to give the lactone shown by the blue arrow. So it is not absorbed orally because the acetoxymethyl group will undergo lactonization in the GIT. It will be break by the esterase enzyme, then undergoes spontaneous lactonization, forming the lactone which is inactive. How to synthesize the 7-amino cephalosporanic acid? And it is very important since most derivatives are synthesized from it. We start here the synthesis by cephalosporin C. Cephalosporin C, we will protect the carboxylic group at position 4 by trimethylsilane. As we see here, the structure here will be the trimethylsilane will be attached to the carboxylic group. Then by phosphorus pentachloride, Here the oxygen shown by the green arrow will be replaced by reaction will take place by an alcohol, then hydrolysis by water, giving cephalosporanic acid. What are the classes of the cephalosporin? They are based on generation. Before we speak about this, we need to say that cephalosporins having advantages over penicillin. What are these advantages? They are low risk of allergic reaction. They are more acid resistant but still cannot be taken orally. They are more penicillinase resistant. They are more broad spectrum against gram-negative but still having narrow spectrum. But they have disadvantages, which are they are difficult to isolate and purify. Why? Because as we saw before, they having a highly polar side chain. In addition to the disadvantages, they have lower potency because they are having less strained ring, as we said before. So the classes of cephalosporin are based on generation. The first generation was introduced in 1960 to 1970. Why we make second and third and fourth generation? Because the first generation having short half-life, narrow spectrum, beta-lactamase sensitive, poor penetration to cerebrospinal fluid. So we have to do to synthesize second, third and fourth. The first one in the first generation is known as cephalocene. As we see here, the cephalocene. Why? Cene coming from thiophene. The blue arrow here showing thiophene ring. Can we take this compound orally? No, because the side chain here in position number 3 is acetyl oxymethyl will undergo lactonization orally. So this compound is taken parenterally. Second compound is cephalexene. As we see here, the structure is similar to ampicillin, having an amino group attached to the alpha carbon, while cefadroxyl is similar to the amoxicillin, having hydroxyl group in the para position of the phenyl, while cefradine here, the phenyl group having 2 double bond and not 3 double bond. The 3 compounds here can be taken orally, because as we see here in the carbon number 3 we have a methyl group, not an acetyl oxymethyl derivative. So there will not be an lactone formation, so we can take it orally. Second generation of cephalosporin was introduced in 1970. The spectrum here is first generation but more active against gram-negative. They are more resistant to beta-lactamase than the first generation. The half-life is similar to its first generation, but they can penetrate better into the cerebrospinal fluid. So they are much better than the first generation, but still having bad or not very good things. Example of it is the first one is cefaclor. From the name chlor, so it have a chlorine atom at position number 3. So it is like cephalexene, but instead of methyl we have here the the chlorine atom. Can be taken orally because there is no acetyl oxymethyl group. Second compound here is known as cefuroxime. From the characteristic things for second generation is the addition of methyl oxyimino group to the side chain, shown by the blue arrow. So the second generation, only the cefaclor only is different, while all the second generation must have a methyl oxyimino group, shown by the blue arrow. Here we say cefuroxime, having FUR coming from furan ring. The red arrow here showing a furan ring. Can we take this compound orally? Here we can take this compound orally and can be taken parenterally. Here the amino group is bioisoster to the methyl group. The third generation of cephalosporin was introduced in 1980. Most of them are semi-synthetic. As we said before, what does semi-synthetic mean? It means that we synthesize it from natural compounds. Since they are semi-synthetic from cephalosporin C, so they are very expensive. Third generation cephalosporins having good stability against the beta-lactamase, and they are having broad spectrum. Most of them are active against Pseudomonas. Most of them are intramuscular or intravenous. Very few of them are orally. So every generation there is a specific group must be attached, but every generation the old group must be present, then we put the another new one. As here, therefore we have to start all the compounds must have what we found it before in the second generation, which is methyl oxyimino. The new group here in the third generation is 2-amino-thiazole ring. So the first compound example for third generation is cefotaxime. The blue arrow here showed the group of the second generation, which is the methyl oxyimino, while the green arrow here showing the new group specific for the third generation, which is the 2-amino-thiazole ring. I said 2-amino-thiazole ring. These compounds cannot be taken orally due to the presence in the side chain acetyl oxymethyl, but it is given parenterally. Another example is cefminoxime. As we see here by the red arrow, the old group specific for the second generation, and the green one showing the new group for the third generation, which is the 2-amino-thiazole, and this compound can be given intravenous or intramuscular. The fourth generation cephalosporin having more resistance to the beta-lactamase, more broad spectrum than the third generation. As we said before, there must be the groups specific for the second and the third generation. So they must have the methyl oxyimino and the 2-amino-thiazole ring group. The new compound here for the first generation is the quaternary ammonium at the C3. Example here is the cefpyrrome. The red arrow here showed the group specific for the second generation, the green one showing the group specific for the third generation, while the blue one showing here the quaternary ammonium group specific for the fourth generation. This compound is taken parenteral. Another example for the fourth generation is the cefepime. The red arrow here showing the second group, the group specific for the second generation. The green one showed the group specific for the third generation, while the blue one showed the quaternary ammonium specific for the fourth generation. This compound also is taken parenteral. There are a group of compounds known as cefamycin, not cephalosporin. What is the difference between cefamycin and the cephalosporin? They are cephalosporin, but at position number 7 there is a methoxy group, 7-alpha methoxy group. They are natural, substituted, isolated from various streptomycin. Therefore, the difference between cefamycin and the cephalosporin is the presence of 7-alpha methoxy group. By modification of this side chain, they become broader in spectrum than the cephalosporin. Why? Due the 7-alpha methoxy make steric hindrance, and also they have higher resistance against beta lactamase. So the cefamycin are broader in spectrum and higher in resistance to beta lactamase than most of cephalosporin. These are an example for cefamycin. We have cefamycin C. As we see here, I put the structure, which is the prototype. Cefamycin C is similar to the cephalosporin C. The only difference is the presence of 7-alpha methoxy and the side chain here having amino instead of methyl, which is isoster. Another example for the cefamycin, we have cefoxetine. As we see here, cefoxetine is similar to cephalocin. The only difference is the presence of 7-alpha methoxy and also the isoster amino in the side chain instead of methyl. Till here we finish the beta-lactam antibiotic, which are penicillin and cephalosporin.